Welcome, everybody. Thank you for coming. For those of you who are not part of this scientific meeting here, just a few words on what is going on right now in Corvallis. We're having here in the LaSalle Stewart Center a meeting of climate researchers that are interested in past climate changes, and 300 scientists from all over the world gather here since Wednesday to document past climate changes and to understand the reasons for the past climate changes. It is a very exciting meeting. It is organized by PAGES, which is an acronym standing for Past Global Changes, which is an organization within the International Geosphere Biosphere Program. So it's an international organization and it's an international meeting here. So the scientists are from all over the world. And so those are the guys with the badges around their necks. You can simply identify them by that. I would like to thank PAGES and Thorsten Kiefer for organizing this public lecture today, which is free and open to the public. And it's a particular pleasure for me to announce the speaker of today, James Hansen. Dr. Hansen is a pioneer in climate change research, and his background is in physics and mathematics and astronomy. He graduated in 1967 from University of Iowa and PhD in physics. And he has become an expert in the radiative transfer, that is the scattering of light and infrared radiation in atmospheres. He started his career with working on planetary atmospheres. I think it was Venus, but probably also other planets. But he moved on in the 70s to study Earth because it became apparent that humans are changing the climate of the Earth by increasing the ozone hole, increasing the ozone hole, so decreasing ozone concentrations and increasing CO2 concentrations, carbon dioxide concentrations in the atmosphere. And he has contributed groundbreaking studies and research on those issues. And he's currently the director of the NASA's Goddard Institute of Space Science, and is a member of the National Academy of Sciences. He has been frequently asked to report on climate change in Congress and in Washington. So we are really lucky to have him here tonight to give us his newest insight on climate change and what might happen in the future. Thank you very much, Jim Hansen, for coming, and welcome. If you need a pointer.
Yes. Thanks very much. This title, a little different than what I had been using, but recently I went to Utah to give some talks in support of Tim DeChristopher. He's a young man, undergraduate at the University of Utah, who you might have heard of. He went to a Bureau of Land Management auction of oil leases of public land, and he managed to outbid the oil companies for a lot of the land, but they found out later he didn't have any money. So now he's charged with 2 felonies with potential 10 years in prison. When I came out there, he said, well, this environment, this pretty conservative country, And they may think of me as an activist, and I should probably explain how it is that I went from doing science to speaking out about it. And yeah, because I had been using a title to the effect of relevance to energy policy and intergenerational justice, but okay, the status of global warming continues to be this gap between what is understood about global warming by the relevant scientific community and what is known by the people who need to know, and that's the public. And that gap is not closing. In fact, I think it's increasing. The truth is that it's become clear from the science that we have an emergency. It is really a crisis, and it's hard for people to understand that. It's the perfect situation. The climate system is the perfect system for creating such a crisis because, first of all, the weather fluctuations from day to day are so large, several 10 or 20 degrees, that it's large in comparison to climate. So people don't notice a climate trend underlying those natural fluctuations. And the climate system has inertia. The ocean is 4 kilometers deep, so it takes it a long time to change its temperature in response to a forcing mechanism. And that means that you have more change that's in the pipeline. Even if we stopped changing atmospheric CO2 today, there would continue to be additional global warming because of this inertia effect. And also the climate system has tipping points. You can reach points where the dynamics of a process begins to take over. And even without additional forcings, you can get large change. For example, if an ice sheet were to begin to disintegrate, once it reaches a certain point, then it's going to continue, even if you start to reduce the amount of CO2 in the atmosphere. It's a dynamical process which would continue out of our control. You can't, an ice sheet is a mile thick. You can't build a wall around the ice sheet. Now, the bad news is that it's become clear that we have already passed into a dangerous amount of atmospheric carbon dioxide. The good news is that it's still possible, if we had appropriate policies, to deal with the problem and even get CO2 to decrease, and doing so would have multiple benefits. But it's not easy. This is, I want to emphasize the intergenerational injustice of the climate issue. This is my first grandchild, and I used this photo first earlier this decade when I gave a talk at Lamont, where the day before there had been a newspaper article that described me as the grandfather of global warming. I didn't know what Wally Broker was going to think about that, but I thought, well, at least I would show that I was a grandfather. So I showed this photo. What was I going to say about that? Well, I had I testified to Congress in the late 1980s a couple of times and decided that I was going to get out of that business of public speaking because I'm not a good speaker, and there are people who actually are very good at explaining things to the public. So when I got requests for television interviews or something, I would refer them to Steve Schneider and Michael Oppenheimer. And I decided I wanted to just work on science. And for 15 years, I kept that policy until 2004. And at that time, it had become clear, first of all, there's this gap between what was clear scientifically and what was known by the public. And secondly, it was also clear that the government really was discouraging the public from understanding that. I found out that our press releases on global warming were being sent by from NASA to the White House, and in some cases thrown in the wastebasket or edited in ways to make the climate problem appear less serious. So when I was asked to give a talk at actually a fundraiser for Democrats, I said I didn't want to do that because I'm not a Democrat, I'm an independent, but I did want to give a talk. And so there was a arrangement where I was going to give a public talk in Washington, and then they decided that this was better not to be done for the sake of that organization. So I ended up giving the talk at the University of Iowa. But anyway, the reason I decided to do that was because of my grandchildren. By that time I had 2 of them. And I decided I didn't want them to say that Opa understood what was going on, but he didn't try to make it clear. So I was going to give one talk, and then it ended up another talk after Ralph Keeling asked me to give one in honor of his father, who had recently died, and then it's continued with some additional talks. But this intergenerational issue, I think, is very important, and it's something which our culture should agree with. There's this famous letter from Thomas Jefferson to James Madison that said it's self-evident that the earth belongs in usufruct to the living, which means that we have a legal right to use something, but we should return it to the owners, which is the next generations, in equally as good condition as we received it from our parents. And that kind of thought is recognized in many different cultures, including Native Americans, who talk about the obligation to the 7th generation. But when I met Larry King, he said that nobody cares about 50 years from now. And I think he was referring to his audience, that he didn't, and of course it's understandable that people have enough problems today without worrying about a few decades from now. But nevertheless, I think parents do care about their children and grandchildren if they understand this issue. This is my newest grandchild, my son's first child, who my parents lived to be about 90 years old, so Jake will probably be around for most of this century, and is likely to feel the full effects of the policies that we choose. Although you don't have to wait till the end of the century to see the climate effects. They're already becoming quite apparent. The status is that there's another gap, and that's between the rhetoric about climate change. The politicians will now say that we have a planet in peril, but the reality of their policies is basically business as usual. So it's more a case of greenwash, in my opinion, than it is a case of really dealing with the matter. We're still waiting for the leadership that's needed to really deal with it. So in effect, what the political leaders are saying to Jake is that you're on your own. And when I look at this picture of Jake, it seems, we're almost saying, well, you're probably going to have to do some geoengineering to deal with this problem. And Jake looks like he's wondering, I wonder what geoengineering is. Okay, so now let's talk about the numbers. So this is global warming for the last century. It's about 0.8 of a degree Celsius, or about 1.5 degrees Fahrenheit, and over land areas it's about 2.5 degrees Fahrenheit, with about 3/4 of that warming occurring in the last 30 years. But you notice one thing that's now said by the skeptics is, well, there hasn't been any warming since 1998. 1998 was a very warm year. This doesn't seem to, it's working, but it doesn't show up on that screen. Okay. And you see that last year, 2008, was quite cool. It was the coolest year since year 2000. That is, however, the variations from year to year, and even to some degree from decade to decade, are natural fluctuations, especially influenced by the tropical Pacific Ocean. The chart on the bottom I think this one this one doesn't work at all, but this one actually works. It's just that this screen, okay, it's there. It's kind of small. Okay. It's if you have good eyesight, you can see this little red dot. So this is the Nino index. The tropical Pacific Ocean, equatorial Pacific Ocean, the temperature oscillates from El Nino's the warm phase to La Nina's a cool phase, and the global ocean surface temperature has a very high correlation to that natural oscillation. And in the last year and a half, we were in a strong La Nina, which is the reason that the 2008 was cool. And we're just now starting to shift into an El Nino. So I think we can expect to see record or near record global temperatures within the next year. Which will disappoint a lot of the skeptics who think that the sun is controlling everything. The sun, there are other factors, of course, that influence global climate, and one of them is the sun. This is the brightness of the sun. We began in the late 1970s to measure the irradiance of the sun very precisely, and you can see that it goes through these 10 to 12 year oscillations coinciding with the sunspot cycle. And we are currently in a solar minimum. In fact, it's the deepest minimum of this period of instrumental data. But we can compare the magnitude of this forcing mechanism to greenhouse gases and CO2. The variation is about 0.1% in the brightness of the sun, and since the Earth absorbs 240 watts per meter squared of energy from the sun, averaged over day and night, averaged over the planet, 0.1% is about 0.2 watts per meter squared. That compares with about 1.5 watts per meter squared for the climate forcing due to increasing CO2. Now that increasing CO2 has already been partially responded to, and we estimate the current energy imbalance of the Earth as about 0.5 watt per meter squared. There's more energy coming in from the sun than there is heat energy going out because of the increasing greenhouse gases which trap the outgoing energy. So the imbalance is only about 0.5 watt per meter squared, although we don't know that as accurately as we'd like to know. It's mainly dependent on the accumulation of heat in the ocean, and we don't have measurements as comprehensively as we'd like in the ocean. But, so therefore 0.2 watt is not negligible in comparison to the energy imbalance of about 0.5 watt, but nevertheless, the Earth is going to continue to get warmer. And we can see these maps are on the left, it's the temperature anomalies in last year, in 2008, relative to the period of climatology, 1951 to 1980. And on the right, it's the anomaly for the first 7 years of this decade, or this century. And you can see, and yellows and reds are warmer than it was on the average in 1950 to 1980. And you can see that essentially everywhere it has become warmer. The warming is larger over land than it is over the ocean, just mainly because of the inertia of the ocean, so it's only partly responded. And it's larger at high latitudes than at low latitudes because of amplifying feedbacks. When ice and snow melts at higher latitudes, that exposes a darker surface which absorbs more sunlight and amplifies the warming. And you can see that 2008, even though on the average it wasn't quite as warm, in fact, other than the Pacific Ocean, it actually is quite warm last year. Nevertheless, you can ask, why should we be concerned about climate change? There have been much larger climate changes during the Earth's history. These were questions actually that were asked by the last NASA administrator on National Public Radio. And they are good questions, and we can answer those or discuss those. And I think the most important basis, the most information that helps us understand this is based on looking at the history of the Earth, because we can see how the Earth responded in the past to changing boundary conditions, including changing atmospheric composition. And also we can look at how the Earth is responding now to the quite rapid human-made changes that we're introducing. And climate models also help us to understand this. And it's good to do all these things together because they assist each other. Okay, so this is a graph of the temperature over the last several 100,000 years. So we live in this interglacial period, relatively warm period, the Holocene, which has existed for about 11,000 years. So entire human recorded history is within the Holocene. This is the temperature near the South Pole, and it's obtained from an ice core. You drill a core into the Antarctic ice sheet, which is formed by snowfall piling up year after year, and as it gets deeper, it compresses the lower parts into ice. And in so doing, it traps bubbles of air, so you can actually sample the composition of the atmosphere as a function of time over this entire period of 400,000 years here, but we have some cores that actually go to about twice that long a time period. And you can see that the temperature fluctuated between these warm interglacial periods and the ice ages, and the variation is about 10 degrees Celsius or 20 degrees Fahrenheit. These oscillations from warm to cold periods, and it is a very large change because the last ice age, 20,000 years ago, there was an ice sheet that covered Canada and reached down and covered parts of the United States, Seattle and Minneapolis and New York, for example. And there was so much water locked up in that ice sheet and a smaller one on Eurasia that sea level was about 110 meters, 350 feet lower at that time. So these are big climate changes, although the variations are smaller at lower latitudes. At the equator, instead of 10 degrees Celsius, it's about 3 or 4 degrees Celsius typically. And on the global average, the change from a glacial to an interglacial is about 5 degrees Celsius. And these natural climate variations are associated with perturbations to the Earth's orbit. As the Earth's orbit about the sun is perturbed by other planets, especially Jupiter and Saturn, because they're so heavy, and Venus comes quite close. And that affects both the tilt of the Earth's spin axis, if this is the spin axis of the Earth going about the sun, that tilt, which is now about 23.5 degrees to the plane of the orbit, wobbles by about plus or minus 1 degree. And as it is tilted more, then you get more sunlight on the pole, and 6 months later you get more sunlight on the South Pole. So that perturbation tends to melt ice when the tilt is larger. The other mechanism that's important is the fact that the season at which the Earth is, the Earth's orbit is an ellipse. It's not a perfect circle. It's slightly elliptical. And the day of the year that the Earth is closest to the sun precesses through the entire calendar from January back to January in about 20,000 years. And that also affects the building of and the melting of ice sheets what we notice empirically, as I mentioned, we can sample the atmospheric composition from the bubbles of air that were trapped in the ice sheet as it was built up. And what you see is that there's more CO2 in the atmosphere and more methane during the warm periods than during the ice ages. And that makes sense because as the let's say the tilt increases, so you melt ice and snow, well, that makes the planet a bit warmer because it exposes darker surfaces, so it absorbs more sunlight, the planet gets warmer, and as the ocean gets warmer, it gives up CO2. Part of it just because of the solubility of CO2 in ocean water decreases as the temperature increases. So the same way your Pepsi loses CO2 as it gets warmer, the same phenomena is affecting the composition of the atmosphere. And if you look at these curves very closely, you find that indeed the gases change slightly after the temperature. There's a lag between the temperature change and the gas change, but then the gas change is an amplifying feedback which increases the magnitude of the temperature perturbation. And it turns out that the entire temperature change is accounted for by just the two mechanisms: the change in atmospheric composition, the increased greenhouse gases when the planet is getting warmer, and the change in the surface reflectivity of the planet, the fact that it absorbs more sunlight when it's warmer and there's less snow. Now, and these large climate changes were instigated by these small changes, small perturbations to the Earth's orbit. But now, those mechanisms, the changes in atmospheric composition, are now completely under control of humans. You can see the methane and CO2 have increased far outside the range that they've existed in hundreds of thousands of years and even millions of years. And the temperature is beginning to respond to that change. But it takes time because of the inertia of the climate system. Now, I think it's helpful to also look at climate changes on longer time scales. It gives you a different perspective on this. If you go back 50 million years ago, this is the deep ocean temperature, which today is very close to 0 degrees, very close to the freezing point, which is 2 or 3 degrees below zero. But 50 million years ago, the planet was much warmer, with a deep ocean temperature of as much as about 13 degrees. It was so warm that there was no ice on the planet. And we know the primary mechanism for that large climate change had to be changes in the atmospheric composition, because it either has to be the energy coming into the planet or some changes in the atmosphere or changes on the surface. But we know the sun is a well-behaved main sequence star, burning hydrogen to make helium in the sun's core, and it's slowly getting brighter over time. So 65 million years ago, it was about 0.4% dimmer than it is now. So its irradiance has increased by about 1 watt per meter squared over that time period. The continents 65 million years ago were already close to their present locations, so the changes in the surface reflectivity due to the continental location is a small forcing, less than about 1 watt per meter squared. But we know that CO2 was as high as 1,000 parts per million 50 million years ago. That compares with a value as low as 170 parts per million during the ice ages. So it's about 3 doublings of CO2, which is a forcing of more than 10 watts per meter squared. So that is clearly the dominant cause of climate change. And it makes sense, because the amount of carbon dioxide in the atmosphere is determined by the balance between the source of CO2, which is volcanoes, which are associated with continental drift. As a continent moves and subducts beneath it ocean floor, that ocean floor, the metamorphosis of that ocean sediments into, because of the high pressure and temperature, into rocks such as basalt and other rocks, is accompanied by the release of carbon dioxide, which comes out of volcanoes and associated seltzer springs, for example. The sink for CO2 is the weathering, is primarily the weathering process, which, when the rivers carry sediments to the ocean, the weathering associated, the chemical reactions associated with that process deposit carbonates on the ocean's floor, and that takes CO2 out of the atmosphere. But those processes do not have to be in exact balance at any given time. It depends on what continental drift is going on. And in particular, we know that 65 million years ago, the one thing that was really different was that India was still south of the equator, but it was moving north at a rapid rate of about 20 centimeters per year. And it was plowing through this so-called Tethys Ocean, or now the Indian Ocean, which had long been the depot center for major rivers of the world. So it was a very carbonate-rich ocean floor. And as India is moving through that, it undoubtedly is pouring CO2 into the atmosphere. As a result, the planet was getting warmer. But 50 million years ago, India crashed into Asia and began pushing up the Himalaya mountains and the Tibetan plateau. And so that source of CO2 was reduced, but the sink was increased because of the weathering of those mountains. And CO2 over the subsequent 50 million years has declined a lot, and the temperature has decreased. And about 34 million years ago, ice began to form to a substantial degree on Antarctica, and it rather quickly froze over. And since then, we have continued to have some ice on the planet. And we have estimated in a paper we published last year that there was ice began to form when CO2 got down to something like 450 plus or minus 100 parts per million. So there are two conclusions from this. First one is that the NASA administrator is right, of course, that there were much larger climate changes naturally. Humans had nothing to do with those. But the rate of the imbalance between the source of CO2 and the sink, geologic sources and sink, is of the order of 1/10,000th of a ppm per year. And over 1 million years, that adds up to a very big change, 100 ppm. But humans are now changing CO2 at a rate of about 2 ppm per year. So we're now 10,000 times more powerful than the natural geologic process. And the other thing is that this also gives us an indication of just how sensitive the climate is. If we burn all the fossil fuels and increase CO2 to 7 or 8 or 900 parts per million, we will be sending the planet back to the ice-free state. It will take a while to get there. The ice sheets don't melt instantaneously, but we would start a process which would be out of control of humanity if we push it that far. So all the countries in the world had agreed in the Framework Convention on Climate Change that we should avoid dangerous human-made interference with climate. The problem is we haven't identified what is dangerous. And I think that at the top of this list should be those things which are irreversible. And that includes the extermination of species, because although there have been relatively large global warmings in the Earth's history, there are several that have occurred, and they were relatively rapid. Nothing like the speed at which humans are changing things, but they were large and rapid enough that they caused the extermination of more than half the species on the planet. And then new ones came into being over timescales of tens and hundreds of thousands of years. But on any timescale that humans can think about, if we drive a significant fraction of species to extinction, it will be a much more desolate planet for any of our any generations that we can think about. And likewise, ice sheets their disintegration is irreversible on timescales that we can think about. It takes thousands of years for an ice sheet to build up from snow piling up. This is an example, the Arctic sea ice, of a process where we may have reached a tipping point. This graph shows the amount, the area of sea ice at the end of the summer, the minimum sea ice, and that fluctuates from year to year depending upon the weather in the Arctic that year. But it has been declining. During this period, we began to make satellite measurements in the late 1970s. And 2 years ago, it suddenly decreased to just over half of what it was 3 decades ago. And we're probably going to lose all of that sea ice within the next few decades because of the amplifying feedback that as you lose the ice, the ocean is much darker, it absorbs more sunlight. But this is not an irreversible process. If we restored the planet's energy balance, or made it slightly negative so that it wanted to cool off, then sea ice could reform. But that would mean, other things being equal, that we would have to reduce CO2 enough to remove the present planetary energy imbalance, and that means you'd have to decrease CO2 to about 350 parts per million, or perhaps less than that. Another thing that gives us a means to estimate target carbon dioxide that we should aim for is the stability of the ice sheets. We see that the area on Greenland that has melting during the summer fluctuates from year to year depending upon the weather that summer, but it has in general been increasing. And that meltwater will go to a low spot on the ice sheet, and it burrows a hole in the ice sheet, and it goes all the way to the base of the ice sheet, and that serves to lubricate the base of the ice sheet. It's one of the processes that contributes to a faster discharge of these giant icebergs to the ocean. And global warming also causes the atmosphere to hold more water vapor, and therefore the amount of snowfall in the winter increases. And it wasn't clear immediately whether the increased snowfall or the increased melting would win out, although common sense tells you that as the planet gets warmer, the ice sheets are probably going to get smaller. And now we have this spectacular measurements of the Earth's gravity field from a satellite called GRACE, and it measures the gravity field with such a high precision that you can see the changes in the mass of the Greenland ice sheet and the Antarctic ice sheet. And during the winter it gets heavier, and during the melting season it loses mass, but overall we can see that it's losing mass at a rate of about 150 cubic kilometers per year. And the West Antarctic ice sheet is also losing mass at a rate almost that large. And that, of course, is a problem because a large fraction of the people in the world live in coastal cities. If we want sea level to be stable, if we want the ice sheets to remain similar in size to their present size, the paleoclimate data would suggest that CO2 should probably not be more than about 300 ppm. But in any case, we can see that 385 ppm, they are unstable. So that's another criterion. And here's another example where we see changes occurring. The overturning circulation, the rising motion in the tropics with the subsiding motion in the subtropics, which causes the subtropics to be dry, that circulation cell in our climate models expands as the planet gets warmer. And we observe empirically that there's already been an expansion of the Hadley circulation by a few degrees of latitude, and that is beginning to affect the southern United States and the Mediterranean region and Australia and parts of Africa and South America. And it's one of the reasons that Lake Mead and Lake Powell are now only half full. And it's also one of the contributing factors that is causing this increase in forest fires in the last few decades. But perhaps one of the most important practical impacts of global warming is the melting of the mountain glaciers, which is observed to be occurring all around the world. These mountain glaciers are important for providing fresh water for actually billions of people. The rivers originating in the Himalayas and the Rocky Mountains and the Andes Mountains receive a significant part of their water in the at the end of the dry seasons, in the end of the summer, from meltwater from glaciers. The Ganges River and the Brahmaputra River, more than half of their water at the end of the dry season is from melting ice. But at the rate that these glaciers are now melting, in about 50 years, most of them will be gone, and that will affect the fresh water supply for a lot of people. Another criterion is we see that coral reefs are under stress, and two of the reasons, there are also other reasons, but two of the reasons are related to this climate change, one of them being the increased surface temperature, which affects the coral, and the other is the acidification of the ocean. And it's hard to use the latter for a quantitative measure of what is a dangerous level, but all of these different mechanisms or effects tell us that we really should be aiming for a CO2 amount of no more than 350 parts per million. And perhaps the optimum level would even be less than that, which is not surprising since civilization has developed in the Holocene, which had a CO2 amount of about 280 parts per million. So if we want to preserve a planet that looks like the one that we know, then we should really keep CO2 less than 350 parts per million on the long run. And the difficulty is that when we put a pulse of CO2 in the atmosphere by burning fossil fuels, it begins to disappear fairly quickly. So after about 20 years, about half of it has disappeared, mostly being taken up by the ocean. But then the ocean begins to resist taking up the rest of it, because the CO2 it has taken up can come back out of the into the atmosphere, and until the CO2 it has taken up is deposited on the ocean floor as carbonates, it won't take up all of the CO2 from the atmosphere. And so after 1,000 years, about a fifth of it is still in the atmosphere. So what that means is we cannot burn all of the fossil fuels. The purple portions of the estimated reserves for oil, gas, and coal, the purple parts are what we've already burned and put into the atmosphere. We probably have used about half of the oil. That's why people think we're now close to peak oil, because that occurs when you've used about half of the resource. But exactly how big the resource is does depend upon how hard you look, and whether you go to the extremes of the earth and get the last drop of oil from all the places. But the real issue is coal and unconventional fossil fuels, shale oil and tar sands, which have a lot of CO2. If we're going to we're going to have any hope of getting back to 350 parts per million and avoiding going to several hundred parts per million, we're going to have to cut off the coal source and the unconventional fossil fuels. If we did that, if we had a moratorium on any new coal use beginning next year, and over the following 20 years, if we phased out the existing ones, then CO2 would peak at something like 400 to 425 parts per million, depending upon what the actual reserves are for oil and gas. And then it would be feasible if we use these lower amounts, and that's why the kind of action that Tim DeChristopher is relevant, because what he's saying is it doesn't make sense to go out after the last drop of oil on public land where there's not really that much oil anyhow, and you'd rather not go after every last drop. But if we use these lower estimates for what remains, then the peak would be about 400 ppm, and we could draw the amount of CO2 down more rapidly by means of improved agricultural and forestry practices, which could reduce, especially reforestation of marginal lands. So it's technically feasible to get back to 350 ppm, but it's not easy, and the most important requirements would be to phase out coal use, and we need to put a price on carbon emissions to encourage the process of going to the post-fossil fuel sources of energy. And the fossil fuels are not going to last forever anyhow, so we may as well move sooner and preserve the climate. It seems to me that the fundamental problem is, and the reason we just stay on this business as usual with our emissions increasing year after year, is that fossil fuels are the lowest price form of energy. Partly because they're subsidized and they're not made to pay for their damages to human health or the climate. The fossil fuel industry has enormous leverage in Washington and the other capitals. I took a few charts from Lori Williams and her husband, Alan Zabel, about this question of cap and trade versus carbon fees, because it appears that the politicians want to go down this cap and trade route, which I claim will be disastrous. It basically keeps us on business as usual, because the problem is that right now fossil fuels are cheaper than renewable energies, carbon-free energies. So the only way you're going to replace and phase out the fossil fuels is if you begin to add a carbon price. And that will make these alternatives more competitive, and it also is going to encourage the investment and the innovations and the use of these on a scale that will drive down their price until they're competitive with fossil fuels. So I'm going a little slower than I wanted to, so let me go a little quicker. Unfortunately, the bill, which is being considered by Congress now, the Waxman-Markey bill, is not going to work, because if you look, it's got 1,400 pages, which have been written mostly by special interests. And they very cleverly put in removal of the ability of EPA to regulate a power plant CO2. And that's why the stocks of coal have gone up recently, one of the reasons. Also, it has very meager targets, and in fact, most of the small reductions that it calls for are actually met by fictitious offsets. Things like where you pay some country to not deforest, but you're not going to stop people from lumbering. The market demand will be met by cutting the tree down someplace else. And also, cap and trade is subject to its speculation and the derivatives. We're going to have the same type of problems that we've had in the last few years with making some millionaires on Wall Street, but not solving the climate problem. As I say, the problem is solvable, and but we would have to take advantage of the potential of energy efficiency and renewable energies and have an improved electric grid. And I think that if those are sufficient, then that's fine. I think that we also have to look at next generation nuclear power, because it's a little difficult to see India and China getting the energy that they want and need from just renewable energies. And there's a lot of potential in next generation nuclear power to solve the nuclear waste problem. The present generation of nuclear power uses less than 1% of the energy in the uranium, but it's possible to actually burn it so that you get close to 100%. And if you do that, and you can also burn what is presently nuclear waste, which is a major problem. But I think the basic problem is this conflict between fossil fuel special interests and young people in nature who just do not have the political clout that the fossil fuel industry does. And that's the basic problem. Now, so the bottom line is, if this is a more or less a valid description of the situation, what are the options? We live in democracy, and we should try to influence the government, but we see from what is happening that we don't, at least I think, that future generations do not have nearly as much influence as the fossil fuel industry. And I give as one example Dick Gephardt, who last year got $120,000. He's a retired congressman, and he's now, last year he got $120,000 per quarter from Peabody Coal to lobby Congress. So that's $500,000 per year. Well, I would like to lobby for my grandchildren, but I don't have that kind of money. It's difficult to influence Washington. Now, there may be a case, and there are going to be some cases that I think where we will attempt to argue that the government has an obligation to future generations. It's not free to set CO2 targets at whatever it wants. It should set them at a level that protects the property rights of future generations. And whether that can be won in court remains to be seen. And of course, the other option is public protests and resistance, which Tim DeChristopher was an example of that, trying to draw attention to the matter. But anyway, it's going to be a continuing problem. It's only going to get bigger. Unless our climate predictions are completely wrong, and I'm sure from our understanding based on the history of the Earth that they're not, we're going to continue to see larger climate changes, and we're going to have to figure out a way to deal with it, which is different than what is being done now, because the targets they're talking about are not going to solve the problem. So I think I'll stop and we can have discussion.
You want to pick
Well, you can do that if you like.
Other questions? I'll wait for the microphone, please.
Is this on? Yeah. Dr. Hansen, I want to ask about policy I've seen you write about, but I haven't heard anywhere else. I want to explain my understanding of it and then ask you why it's not being discussed at all in Washington, because from my understanding, there's no downside. You call it 100% dividend or fight. And the idea is the producer of a product or service pays a fee to the government based on per unit CO2 emitted during the process. But they don't mind because they just pass that cost on to the consumer. But the consumer doesn't mind because the government takes all of that money, puts it in a pot, and then divides it up in equal shares for every taxpayer, and then gives that rebate or that dividend check to every consumer. So my understanding is, as a consumer, if I purchase products that have an average CO2 footprint, the policy makes no difference to me. If I am economical about it, I actually make money on it. There's no doubt the government doesn't get to tax and spend, so it dodges that bullet. It's friendly to business, so it dodges that bullet. It preserves consumer choice. People can still buy their SUVs. It dodges that bullet. And it involves the marketplace in driving innovation for lower CO2 products. So my question is, why the hell is no one talking about it?
Well, yeah, actually, I'm going to Washington on Monday to do a briefing at the Senate with some other people on just that topic, on to compare cap and trade to what's sometimes called tax and dividend. It probably would have been better to call it fee and a dividend or fee and rebate. But that's right, because and you know, the cap and trade, they're trying to say, oh, that won't increase the price of energy. Well, if it doesn't, it's not going to have much effect. It will actually increase the price, but if you want to change people's practices, you have to have a significant change. When oil went up, gas went up to $4 a gallon, that was enough that it would affect people's choices on the long run. But that's the kind of thing which will oscillate, you know, and so people don't know, is that going to stay up there? Well, that's why you want to have a gradually increasing price on carbon emissions. I think that's the logical solution, but of course, this, you know, almost every economist will agree with that. That's the way you should do it, because then you have a known change in the price, and then people will be willing to invest. If you do it with this cap, which then you end up with speculation, so that oscillates. The impact on prices may crash the way it did when the Europeans introduced a cap and trade. So yeah, no, it's very logical, and it's remarkable that. And when I ask people, when Al Gore was testifying a couple of months ago, I called him up the night before he's going to testify, because I knew he was going to say, oh, he goes along with the Waxman-Markey, that would be a very good idea. And we talked about exactly this, and he said, no, of course you're right, that's a much better thing to do, but, you know, it can't happen. You know, the train has left the station or something. The problem is that the train that has left the station is not going to work. And it's the cap and trade is the Kyoto Protocol approach. And if you look at what happened, even the countries that had the strongest accepted and met their obligations. Japan is a good example. It accepted the strong goal, and it says that it met it. But now I've made graphs of their CO2 emissions, and they went up significantly because their coal use went up. And how did that happen? Because they bought these offsets, which supposedly would reduce the emissions in the country where they bought the offsets, which is China. But China's emissions went up exponentially. So it doesn't work. And the only way, fundamentally, unless you have a price, as long as fossil fuels are the cheapest form of energy, they're going to be used. So you have to affect that. And I hope that it's still possible to get Washington to understand that. But there are a lot of people who don't want to understand it because they can see that they're going to gain from cap and trade. Utilities are fighting very hard, you know, and it's a case of greenwash. Jim Rogers, who's the head of one of the biggest utilities, Duke Energy, manages to talk the greenwash story very well, and he's he's basically written a large fraction of the Waxman-Markey bill, including the fact that he's allowed to build new coal-fired power plants. He's managed to get them into the bill, and they're allowed to trade in these permits. They're going to get a lot of free permits, which is a boon to them, but it's unfortunately it means that we're not going to solve the problem.
Are there other questions? Here in the front.
Hi, Dr. Hansen. I read a United Nations report. It says that the animal or livestock production in USA causes more greenhouse gas than all transportation combined in the world. So would you please comment on how minimizing livestock production or how we change diet to eat less meat or no meat would help with global warming? Thank you.
Well, I don't know about those numbers. I don't think that it's really that large, but it is a significant contributor to greenhouse gases. Although many of the personal things you can do, I almost agree with Dick Cheney that some of the things which you can do may make you feel better, but they don't really solve the problem. For example, and if the government continues to do what it's doing, because if you reduce your oil use, it just reduces the price. If enough people reduce their oil use, it reduces the cost of it, and somebody else will burn it because it's so cheap. So unless the government is taking the steps to it, that kind of action, there's a negative feedback. But one action that you can take that has a clear benefit is, in fact, reducing your meat consumption, because that eating lower on the food chain. Vegetarianism is a good way to do that. But you know what's happening, of course, is other parts of the world get wealthier. They're becoming more meat eating. So that continues to be a source, but nevertheless, the fossil fuels on the long run are the dominant source.
There's a question here.
Do you think enough scientists are speaking out about the problem, making their voice heard, and if not, why not, in your opinion?
Well, I can tell you, why not? I mean, it takes, I mean, in my case, it takes a lot of time, and it does reduce your ability to do the science, which is what we really want to do. I think the scientists have actually made the story pretty clear, and it only is not understood because the special interests have been so effective in muddying the story. I was surprised, for example, that even National Public Radio, Jim Lehrer program, I was asked to go on that, and I was told, but we're also having one of the contrarians, because we have to have a balanced presentation. And with a little investigation, I found out that that's because some of their sponsors demand that. And in any case, the public is not well informed, but I think it's not because the scientists, through the mechanisms like the IPCC and the National Academy of Sciences, have made a pretty clear story, but it's has not affected policy the way that it should, given the information we have. It's, you know, I had misunderstood the likely impact back in the late 1980s because it seemed to be analogous to the ozone story, where the information from the scientists did have an effect, but that was a very different story where you had only one source and really one company, DuPont. And at one point, DuPont told President Reagan that it was okay to require these to be phased out because by that time they had substitutes and they made just as much money off the substitutes. And so you would hope that energy companies would have a similar, would start investing their resources in carbon-free energies and become energy companies rather than fossil fuel companies, but that's not what they're doing. They're instead doing what they can to avoid the government putting a price on carbon emissions.
Maybe from this left side here.
Hello. Yeah, I feel like when we're talking about this thing, we're really picking easy villains to fight against. We all know the fundamental problem is the 6 billion people we have in this world. Unless we get control on the population growth, and we can cut U.S. carbon emission by 90%, and when the rest of the world get all the indoor plumbing and indoor heating, the carbon emission is going to be up there. So why there is very little talk about a population problem?
That's a really good question because it does point out something which is not usually discussed, and I don't know why. I think it's because maybe reluctant to try to, but it is difficult to see. You had another question about animals and the meat diet and things. Well, yeah, if the population keeps going up, there are these various things which will make it very difficult to solve the problem. But I think there's some reason for optimism on that score. I do think that we should point it out more frequently than we do, but you know, in a large fraction of the developed countries, the fertility rate has gone down to the point that populations eventually, even though people are living longer, so the populations are continuing to increase even in the West, but we can see that population will stabilize in many countries and even begin to decrease. But that would need to occur in the whole world. And in Africa, of course, the population growth rate is still quite high. But nevertheless, it's true that education and the fact that people now, communication is much better, and having many children has become rather unpopular with women in most countries. So I think there's hope on that score, and I do think that is a fundamental issue, that it's going to be hard to solve this problem if population keeps going up.
Two questions, please. First, I wanted to ask about biochar. Would you please evaluate, in your judgment, the potential of biochar as a form of carbon sequestration? And secondly, this morning on a talk radio show, I heard the claim that the great majority of energy usage was by the military-industrial complex, so that people putting compact fluorescent bulbs in and people using sunshine to dry clothes and doing the things we can do was just literally a drop in the bucket. Would you agree that maybe 2/3 of the energy is used by military and industrial agencies?
Okay, let me first discuss biochar. We had in our paper where we try to discuss actions that we needed to get back to 350 ppm. We do mention biochar, but in the scenario that we showed, it was a small, we only were counting on that for a small decrease in atmospheric CO2. But it is true that presently the soils are a source of CO2 because of our agricultural practices. The way we plow up the land, it's harder for the soil to retain its carbon. But there are alternative ways as to how you improve the soil carbon situation. You can leave litter on the ground, and you can use low-till or no-till agriculture, and it's not yet clear whether, if you're going to use biochar, there are ways you could do it that would actually be harmful. It depends on where you're getting the material that you're using to make the charcoal that you then work into the soil. The question, I should mention, refers to the idea that if you work charcoal into the soil, you can make the soil actually more productive and at the same time hold more carbon. And there are certain places on the earth where that's been demonstrated, and there have been some people over timescales of the last few thousand years who actually did that, but that doesn't necessarily work every place. The lifetime of the charcoal, it may not be as long in some places on the earth as it is in others, and we need to compare that using the plant waste and animal waste to make charcoal to the alternative of using that material for as litter, which also increases the fertility of the soil. But clearly there are some situations where biochar can help, and you just have to do that intelligently, and we haven't done all the research and experimentation to determine exactly how much it can help. With regard to your second question, I think that's a gross exaggeration. We do know very well where the CO2 is coming from. Because the three sources, oil, gas, and coal, are internationally traded commodities, we know where they're coming from and where they're being used. And the military is guilty of using fossil fuels very inefficiently. And the U.S. military is beginning to listen to that, and I think President Obama is encouraging them to look at their energy efficiency. But in terms of their total fraction of the emissions, the military is not a major source. You say industrial complex. Well, it depends if you're what you're counting in that. But nevertheless, transportation is about 1/3 of the CO2 source, and buildings, heating and cooling is a big part, and then industry is another. So there are three big sources there.
I live in geek land, My husband works for HP. I live in geek land. My husband works for HP, and they pass around all sorts of little geek videos. So he showed me one last night. It was absolutely incredible, and my question relates to that. It was a video on the Popular Mechanics website, and this young inventor of 24 had taken a mylar impregnate fabric and created a thin band, stretched it taut, attached magnets on the end, and as this band was oscillated by a fan, and in real life, he was saying that they could stretch it across large valleys and oscillated by the wind, such as the bridge in the Narrows in Washington was destroyed by the wind. It oscillated in that fashion. And the magnets hit copper coils at the end and created electricity for pennies. My question to you is, how much will these microtechnologies affect our energy production in the future?
Well, I wouldn't be surprised if there are not alternatives to fossil fuels, and the way to find those is to incentivize it with a price on carbon emissions, and that will drive that. Then you will have investors who will invest in these different things, and some things are going to probably pan out, but as long as fossil fuels are dirt cheap and they don't have to pay for the damage that they do, then I doubt that anything else is going to be taking over.